Welcome to Study Loop.
Okay, folks, so in this video, we're going to be talking about this problem. As you can see in the picture, an electron moving at speed v equals 100 meters per second along an x-axis through a uniform electric and magnetic fields. So we have this particle, and it's an electron, and it's moving with a non-zero velocity along the x-axis under two fields, under the influence of two fields, an electric field and a B field, okay? And the B field is directed into the page, and it has magnitude 5 teslas. And what we're looking for is the electric field vector in unit vector notation, okay? So how are we going to do this? This is actually a very straightforward problem as soon as you realize, as soon as you understand this problem conceptually. So first, I want to remind you that when you have a charged particle with a non-zero velocity and it is moving in a B field, that particle is not going to be moving straight in a straight path. It's not gonna. The reason it's not going to is because of the magnetic force. It is given by q v cross b. So in other words, if this is its velocity vector and there is a B field that points into the page, then this particle is going to be deflected. It's going to swirl around, right, in a circle. So the only reason that in this problem this particle is not moving in a circle is because of the presence of the electric field. So that electric field has to balance out. It has to balance out the effects of the B field on the particle. So if the B field gives the particle a force in the y-hat direction, then that E field better gives it the same amount of force, but in the negative y-hat direction. Okay, so that's where we're starting with. We're starting with the idea that the B field wants the particle to swirl around, and the E field undoes that effect. Okay, so we know that we know about the charge of the electron, and we know about the velocity of the electron. They're both given, and we also know about the B field, right? We know everything, and we can calculate the magnetic force. And as soon as we have that magnetic force, the electric force, it better be the negative of that. It better be the negative of the magnetic force, so that when you add them up, you get zero. You get zero force in the vertical direction, right? That's what we want. We want zero force in the vertical direction so that the particle does not accelerate in the vertical direction. Okay, so let's calculate first of all. Well, hold on one second. Before we calculate the magnetic force, I just want to remind you that in this problem, we're not looking for the force of the electric field. We're looking for the electric field itself. That means what we're going to do is we're going to divide this by the charge. Okay, we're going to divide this by the charge. Okay, and this is going to give you the electric field, because the force due to the electric field is going to be Q times the electric field. So if you divide this by Q, you get E. Okay, so let's do this. We have, so what is FB? Well, the FB is, it is, I'm just putting this negative sign because there's a negative sign here. Anyway, it is going to be Q 100 times 5, and the whole thing divided by Q. If you divide the whole thing by Q, there's a Q on top, a Q on bottom. You cancel them out, you get negative 500 in the y-hat direction. Let me see if that's correct. Yes, that is actually, well, let's see. Our answer tells us that this force, that this E field points in the negative y-hat direction, and that is correct. This E field points in the negative y-hat direction, but because of the fact that this electric field is influencing not a positively charged particle, it is influencing an electron, which is a negatively charged particle. So the force due to this E field is going to be pointing upward. Okay, and the B field gives it a force pointing downward. Okay, that's just a little bit of a reminder on directions and charges and whatever. Okay, anyway, so this is the electric field. Okay, in this problem, it is negative 500 in the y hat direction, and the unit is going to be volts per meter, of course. All right, so this is the answer. I'll see you in the next video.